Learn cybersecurity and focus technical training with justhacking.com, where all-star instructors and industry experts provide hands-on, affordable, and practical learning. Across courses, free upskill challenges, hack-along training videos, and capture the flag competitions, there's always something to hack. With new content twice a month, all throughout the year, plus bi-monthly live streams, you can sharpen your skills in our on-demand and interactive lab environments. Advance your career and level up, regardless of your experience or budget. Forget all the noise and get to Just Hacking. Sign up now at justhacking.com. Hello, everybody. Welcome. Welcome to the show. Welcome to the live stream. It always feels so funny, trying to kick this thing off, getting the sizzle reel going up to amp everybody up, to hype up the crowd. And then it's still just me. Just me sitting alone in my room, yelling at my computer, having a lot of fun. But really appreciate you all jumping in to join and hang out for a little bit for another Just Hacking Training live stream. Granted, we're doing a fun little training week because yesterday, you might have caught us, we were hanging out with Mishal Khan, to chat about some OSINT, open source intelligence, and a little bit of the OPSEC or operational security work that he's doing. He's a genius, he's a wizard, and he's sharing some of that sweet stuff over on Just Hacking Training, along with myself. So today, I'm the guy. I'm the one on the chopping block today. I'm flying solo. It's just me here to hang out and have some fun with you all. But look, I gotta be real with y'all. Today's kind of a busy day. I'm running around a little bit. There's a lot going on. So after this live stream with you all, I got to bounce over, put on the day job hat and shirt, and do a little webinar for Huntress. So that will be back to back, and then there's some more meetings, and the call meeting marathon that follows, and then all the other shenanigans. While I'm hyping up, getting ready to go over to B-Sides New York City this weekend for their keynote, and then following that SaintCon, and then following that Virginia CyberCon, and then following that B-Side Chicago. So it's October. Wow. Wowie zowie. Cybersecurity Awareness Month, or for me, Burnout Month. But look, really appreciate you all coming to hang out and be here with me. So look, it's a Just Hacking Training live stream, which means by default, I de facto get the excuse and opportunity to talk shop, to show y'all what we've been up to, what we've been doing. And I'm going to go ahead and share my screen, if that's okay. We'll do some of the fun demos, and then I'm going to try to get a good layout here. I hope this works. Does that work? Does that look good? Is that okay? I think it's good. You let me know. I feel like I could change my name to John. That's fine. Okay. Thanks. Live and production with just me. You get all the fun, raw, and hilarious insanity of me running the show all on my lonesome. While I'm going to be doing some screen share and bouncing around back and forth, look, I'm online at justhacking.com, and this is home base. This is HQ. This is where all the magic happens for our extra endeavor to get some training, to get some courseware, to get some education and more material out and about for you with practical hands-on labs, activities, and exercises. So it's focused technical training for all levels, is what we like to say. And we're doing something super cool. If you haven't been tracking, I know I've been screaming and shouting about this, but it's for a good reason. We are doing some live and in-person training at B-Side Chicago coming up at the end of the month. So I'm really looking forward to that because, look, that's kind of like a goal. That's like a milestone in its own right to be able to bring this education, this content, and this training IRL, in the real life, in real world stuff. So I'll be there teaching some script-based malware analysis. I'm also their lock note or their closing keynote. Mishal will be teaching some of his OSINT, open source intelligence work. And I don't know if Ellie will actually be able to make it, unfortunately. I'm a little bit bummed that one might not hit the sunlight that it should. But Trevor will be there. Trevor is rocking Hardware Hacking 101 with a take-home kit. So you do get some little extracurricular souvenir, something fun to bring home and keep hacking all on your own. But since I am today's victim for our training week of live streams, I'm going to be chatting a little bit about the script-based malware analysis course. But let me be real with you. Again, I'm going to be honest. This is kind of going to be a short live stream because I'm back to back, baby. I got a lot of stuff today. But let's dive in. Let's have some fun. If you weren't tracking, the script-based malware analysis course is over in the courses and paths sections of the landing page and website. And let me get the proper zoom here going. Obviously, we've got a ton of sweet stuff in here. If you caught our anniversary live stream or like our birthday live stream, we were just celebrating. Goodness, we're up to like almost 80 different offerings now, which is kind of awesome for just 1 year. A lot of blue team, a lot of red team, both offense and defense, some malware development, some dark web, some Active Directory, some cryptography, of course, OSINT and OPSEC, tons and tons of stuff. But I'm looking for my script-based malware analysis. There we go. So script-based malware analysis is actually kind of built off of a workshop that I put together. And I don't know if folks are familiar, that's kind of maybe a fun fact, but of course you've got a Windows virtual machine, you've got a Linux virtual machine, and all to be able to play with it. And we could dive in, but I'm not going to drag us through all of the course and material, because that is something that, you know, we're having fun with the exclusive training over there at B-Side Chicago. And if I didn't already say, look, it's something that we're going to have meals provided, lunch provided, full hangout, 8-hour workshop, 8-hour day to be able to be there with all of us, and then ask your questions, and then dig into anything that you're interested in, and then chat a little bit about anything else you are into. That's really the value, I think, of IRL in real life training and live and in-person stuff. So you have some of the expert-led material and education there. But this, of course, goes through a whole lot of script-based malware work. Nothing that we need to dig into Ghidra or IDA or Binary Ninja or all some of those things that are obviously low level, like compiled code. Like, oh, you're cutting up in disassembly, you're using a debugger, you're setting breakpoints here and there. You can still do that, of course, with some of the script-based malware analysis stuff, working in a debugger, but don't need to get into hardcore machine code, opcodes, and instructions assembly. So that is what we're having fun with in script-based analysis. I think it's a little bit more approachable, especially for folks that are really interested in this thing. But you know I'm hyping it up. You know I am trying to beat the drum for B-Side Chicago. Hyped for this. We'll have some links flying around in chat. I think we'll, again, really try to get a little bit more eyes on some of the awesome stuff that we are up to there. Featured workshops, me and Mishal and Trevor. So it looks like Ellie, unfortunately, won't be able to make it this time around, but we are stoked to be there. Now I got to be real with you once again. I see a question in chat. John, are you pre-recording? No, we don't pre-record stuff. We always do it live. For better or for worse, when it's always an improv show, you know, we're out here making a fool of ourselves. I've made that my career, is to professionally look like an idiot on the internet. But we have a lot of fun. Let me get to it. I'm gonna hit two birds with one stone here. So I'm letting you know straight up, we, for a little bit of a demo, for a little bit of our fun, we will walk through one of the more script-based malware analysis challenges from the Huntress CTF. I think this is actually genuinely, though, one of the best ways for us to be able to explore into this, because this way it's immediately accessible for you. If you wanted to dive in, you can. This URL is ctf.huntress.com. And of course, there are new challenges rolling out every single day. So if you are online across the interweb airwaves and still wanted some fun activities, maybe you could jump into the Huntress CTF. So the very first challenge that we could kind of take a look at, if I were to get back into the game here, I'm inside of my Kali Linux virtual machine. So we will be able to work through the Verify You Are Human task and challenge. If you were to go take a look at some of the other things that are available here, obviously you might realize and recognize, hey, this is the same sort of platform that Just Hacking Training is built on top of. Core Stack is phenomenal, and we'll be hanging out with them super duper soon for the Tradecraft Tuesday webinar I've got right after this. And this lets us give you full-blown virtual machines and VPN connectivity, which is exactly why we love all that sweet stuff in JHT, or Just Hacking Training. So what we could do while we're exploring some of the challenges that have been released already every day through the month of October, I'm going to bring us way back to the start. I'm going to bring us to our day 1 challenge. And this was to give us a little bit more meat, a little bit more substance to a task, rather than it being kind of a warm-ups or one of those baby beginner, simple one-step solution tasks. But that will open the door for us for some script-based malware analysis. And we'll lean into this with ClickFix. If you aren't tracking or you aren't familiar, it's not pre-recorded, everybody. Chat, what are you doing? Chat, what's wrong with you? Verify You Are Human is the challenge that presents a kind of CAPTCHA-like I'm not a robot button and ClickFix malware. This is actually one of real samples. This is something that we had seen out on the interwebs doing damage. And a lot of the malware challenges and categories, especially within the Hunter CTF, and what you work through in the exercises of the B-Side Chicago live training IRL experience, and of course, the on-demand training and material and workshop, then you're getting real stuff. You're getting actual samples that have some malicious things in there. So CX Space, you need me to say your name so you understand it's live. It is live. I see you all. I'm seeing you through the internet airwaves and chat. So let's go ahead and spin up our Verify Your Human task. I'm going to go ahead and click the Start button here. And I mentioned I am inside of my Kali Linux virtual machine. Now, because I want to go tackle this challenge, and it is Windows-like malware, being in the ClickFix Verify Your Human CAPTCHA sort of setup, I like to be in the opposite or maybe different other operating system that the malware would naturally execute in. Because things like JScript or VBScript or PowerShell aren't naturally going to execute on Linux. And that way, I have a little bit of extra security. Well, of course, we're inside of a virtual machine. Internet is off when we need it to be off, et cetera, et cetera. So let's get to it. We could connect to this via the browser-based connectivity. Let me go ahead and click this, and that will bring us into the challenge. And I know this looks a little bit convincing, if I may say. If I do dare, this looks like one of those Verify Your Human CAPTCHAs. And I gotta honestly admit, I think we had some folks stumble on this, not tracking the fact that this is a CTF challenge with the big red caution warning. This is the malware category. This is related to MS Teams and a CAPTCHA. So we wanted to make this even more clear the best we can, but probably in retrospect, it really would have been worth like a JavaScript alert or a pop-up that said, reminder, this is a CTF challenge. It's the malware category. Don't actually run this. Because what this does, when we go ahead and click the button, and before I do, I actually want to get us into the VPN because I do really like the VPN connectivity a lot more. The Systems tab here, while we could scroll through and start any of the other challenges, let me go ahead and download the Staging Hunter CTF VPN, and you can see some of my other preparations before we got started. But let me open up a terminal with Control-Alt-T. Let me make a directory for Hunter CTF for us to work in. It already exists. Excellent. And I can move into that directory, and there's nothing in here currently, but let's go move our staging, and I put that in downloads, didn't I? Because it had the extra 1 to it. I do want to make sure that is going to be here. And let's put it in just staging Hunter CTF. .ovpn. Okay. So we can connect to our VPN, easy peasy, and let's just do it out of the current directory since we put that here. And now we are connected. And I'm using Terminator, so I like to use the little hotkey to be able to split my terminal screen. And then let's just validate and verify we could ping this machine. Looks like it's good. It's coming through. So VPN is connected. Now let's go ahead and browse to it in a web browser. Cool. So same exact input. Of course, this is the same challenge. Now let's get to it. The verify your human task for our click fix malware. Once we click the button, it tells us, look, this is the click fix social engineering lure. Press and hold the Windows key on your keyboard. Press Control V after you've pressed R to open up the run dialog box, and then press enter on your keyboard to finish. So pasting in a payload that this website has already pre-poisoned or set up in our clipboard. If I were to paste this in, even in just the address bar, I know you can't see that super duper well, but there's a lot of code here. So let's go ahead and make like a stage1.cmd command, and then let me paste in what this tried to run. So I'm going to turn word wrap on, and I'm going to make this a little bit bigger. Now we're looking at script code, right? PowerShell in this scenario. It's running off of Windows, the native, natural, living off the land binary for running PowerShell with some arguments here. I'll add some white space or new line so you can see this a little bit better. TAC WI, short, like truncated argument or parameter for the window mode. HI does not mean high. That means a hidden window. If I could type, wow. Okay, cool. So it's hiding PowerShell. It's using TAC NOP or NOP for no profile. So it's not going to load whatever user might be logged in with their specific profile. And then TAC C to run a command. Everything that follows in the double quotes there in yellow is the command that it runs. So realistically, we could take this chunk and do we dare call that stage 2? It is just what's being prepped and set as the cradle for this PowerShell command. So let's run, sure, a stage 2.ps1, since we know that is PowerShell script. Yeah? Let's turn word wrap on. We can remove the double quotes because that's no longer being treated as if it were an argument in PowerShell. This is now just us looking at that code that it tried to run. Now, I like to try to chunk up different semicolons because that usually means, okay, it's a new command. It's new logic. It's another commandlet that's being executed and ran. So while this is not ideal, trying to beautify this code, normally you should use something like Visual Studio Code in all reality, because that has a PowerShell beautifier or formatter that will make this a little bit more easy to work through and see. But because there's not a lot of lines of code in here, let me replace a semicolon to denote a new command with a new line. And actually we can add another so that's a little bit even more readable. So here is what it does. Random variable, denoted with the $sign, is set to something out of your local app data directory that's stored as an environment variable in PowerShell. And they use a backslash to put something into that directory, or referencing that as a value. And they just get a random number. And they add a .ps1 or PowerShell extension onto that. So probably going to be seeing more PowerShell used however this variable is used. And if we look for it, we do see it used later on. Looks like it's actually using IRM, which is the PowerShell alias, like a nickname or shorthand representation of a function or commandlet for invoke REST method. Now that's very similar to IWR, to invoke web request, because you're basically going to be reaching out or pulling something down from the internet. So you can see the very following URL here actually harkens back to the same instance of the IP address that we were just beaten up. Okay, so there's another little blob or payload and data that it's going to put into that PowerShell script that it just staged and then try to run that with another hidden window and now TAC EP for the execution policy to bypass. So Do we have a course for OSINT? Yes, we do. Michelle Kahn has been teaching a ton of sweet stuff with OSINT. You could check those out, justhacking.com. We might have a couple more links flying around in chat. So it executes this script after it downloads that next payload from this URL. Granted, it's the exact same IP address, but with the cutesy little HTTP parameter. So let's try to go get that. Back in our web browser, we could literally go to that URL, just hit enter, and now there's more code, more PowerShell stuff for us to dig through. So what I will do is now basically call this, stage 3? Stage 3.ps1. And because this is PowerShell, I do have the PowerShell plugin installed within Sublime Text, so it has added the syntax highlighting. But now we've got a little bit more to cut up. And this is where that trick of our semicolons being replaced with new lines will make this a little bit easier to see and make sense of. Now that's a bit more readable, not as much of a blob. And we've got more randomly named variables. Now, we could walk through this whole process and try to deobfuscate or make sense of what each of these variables and strings are being set as. Thing is, this is in PowerShell. So the syntax for that to be running on Windows, well, we could let PowerShell evaluate itself as long as we kind of defuse or take out the detonators for what will trigger or fire off and run a new stage or payload of the malware. That's a very clever trick. That's a little trick with scripting languages, especially when you can get into an interpreter. Can you just let it run? And I know that's sketchy. I know that's scary. Oh, just let malware execute. But if you're doing that side by side with your static analysis, and then you can sort of, find and see where it's going to be pulling the next payload or actually executing any of the things that it's tried to prep or stage, then you can be smart about it. So I say that because I'm curious what these characters are. You can see the parentheses and square braces CHAR for a car. Now these are, of course, like ASCII representations of letters. And granted, that's, the ASCII range 0 to 255, but we could just find out what that is. And here's the thing. Remember, I wanted to be on Linux. I wanted to be in Kali or Remnux or whatever, doing some of the opposite analysis from another distribution or operating system the malware runs on. But PowerShell is cross-platform. So I could just get into PowerShell, PWSH when it's installed in Kali Linux, and then I could use the exact same syntax that they use in the malware sample. So I could just paste in all those characters and see what this would evaluate to, just as the real value for that variable. So something small, something tiny, .pyc, probably a file extension for Python compiled bytecode. Thank you in the chat. Yes, not pre-recorded. I'm grateful for the big diamonds and the banner display. We are live. We're doing it live. So, we could now change that variable name if we wanted to. We could say like Python extension and change the name of how that's used. Then we get a GUID or a unique identifier in the Windows world. I wonder if that will work within cross-platform PowerShell. It does. So because that's randomly generated, it will be different every single time you try to run or get a new GUID. This was kind of neat and interesting when we were working to help the folks that did accidentally probably run this malware sample, air quotes, malware sample on a host, because we were trying to tell them, look, the breadcrumbs for this are ending up inside of your local app data directory. Chat, what is going on? Why are we still talking about the pre-recorded stuff? I don't know. I'm giving you the light of day. How in the world was it able to access the clipboard? Okay, good question. I'm sorry. I took a break to go look at chat and look at some of the questions that were coming through. When we first started here at this webpage, the beginning start and initial point of the challenge, ClickFix, the ClickFix malware variant, and this whole family of threats. takes advantage of this by literally prompting you to go through these instructions. However, your web browser, Firefox, Google Chrome, Brave, Safari, whatever, Internet Explorer, if people are still doing that, Microsoft Edge, it gives the end user, the client, the website, access to your clipboard. So they could write into it. And let me actually show you. Let's hit Control U and let's go see the source code here. There's a lot of boilerplate CSS, cascading style sheets. And then if we scroll down, we could see a little bit more of the logic and some of the JavaScript that might be included here. Here's an unsecured copy to clipboard function that actually ends up copying to your clipboard by adding in a text area element, selecting it all, and then using document exec command copy. That literally puts something into your clipboard via the web browser. Cool. Capture check does the same thing. And if you look through this page, I left a little bit of an Easter egg in here. This did have the raw OG original like URL or C2 that they used, and some of the Cyrillic characters, Russian comments to see how this would be executed. But they were escaping and base64 decoding what would have been that giant payload that we saw and worked through with PowerShell. So I hope that answered your question, getting into the clipboard in the browser. Let me go back to real chat. Thanks, everybody. I really appreciate all your interest. I'm grateful, and I hope you do get a chance to play and poke around the Huntress CTF. It's running all month. And this is a good example to do some script-based analysis work. So the next variable is getting some environment variable values again, getting our local app data. So we can just change that to local app data. And I'm keeping an eye on the clock because I do need to dash soon. Looks like we download another payload. You can see this IRM command, another invoke REST method commandlet. Now going to tick 2 when the other one was tick 1. So it looks like they download this into a PDF file format and they actually extract this using some C# magic. They add in another assembly for some .NET assembly, extra power for PowerShell. And with that, we could go ahead and extract the PDF, which is interesting because that's telling us that's not a PDF file, it's a zip file. And then they go ahead and join some of the paths together, finding the Python executable, looking for some compiled Python or bytecode there, and they add a scheduled task based off of some more of the random variable names, likely the GUIDs that they've chosen. We could keep connecting the dots here if we wanted to. Then they add just a couple minutes, 3 minutes worth, 180 seconds, to start and trigger a new scheduled task. So it's going to end up executing and adding another little stage or payload here using some Python code, presumably, with the DLLs that are all included for compiled Python on Windows. And they do something very clever here. They run the set clipboard command, which in PowerShell means it's going to use the clipboard and set it to whatever value you provide, but there is no value provided here. It's like they entered an empty string. So they're clearing out the history or whatever they just put into your clipboard in that click fix malware shenanigans. But we know we've got another payload here. We know we can dig into tick 2 across that host. So let's go to that. And we are still connected over the VPN. But this doesn't give us much because it thinks it's a PDF, right? Like our web browser is trying to render a document, but it's not real. It doesn't exist. It's causing an error. And you might have seen that error if you were playing the game here. So what we could do is we could save this file. We could put it in downloads for the moment and download that and start to work with it. Knowing that this is going to extract it, considering it's actually a zip file, not a PDF document. So let's get back to our terminal. Let me get out of PowerShell for the moment. And let me move from my downloads the document.pdf that we had, and let me run the file command on that. And realistically, is this like stage 4? File tells us that it is a zip archive, which makes sense, which tracks with everything in the code that we were just looking at. So let me actually change that to, what was it, literally stage 4, I suppose. Document.pdf we know is a zip archive, so let's call it stage4.zip. And then I will extract it with 7-zip from the command line, and let's see if it can rip out all the contents there. What might be a good idea, though, is probably making a directory so that we could actually see all the files that it includes, but not clutter up everything else that is in our current directory. So let me move that directory, or move that file into that directory. Does that make sense? Now I'm not going to clutter up everything else in the previous parent directory, but just in this new directory that I made. So not making a mess. Let's use 7-zip to extract. That extracted A-OK, which is the same procedure that the PowerShell code went through. They're just using the .NET utility to extract it into the app data new GUID random name that they chose. But we have extracted everything out. So what do we got? A lot of Python boilerplate. And this is all the same artifacts you'd probably pretty much always see when you have a compiled Python executable file, or a .exe like Windows program bundled up, made from Python in the Python scripting language. That'll include all the DLLs that come with Python, some of the standard libraries that they use, blah, 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 stuff that would ship with Python being able to naturally run. Now, some neat things though. Normally when you see this, you have just a handful of .pyc files, but you'll note they did reference in the PowerShell code this pythonw.exe, and they were calling that with the C Python 3134 PyC code. But if I take a look at that, it tells me it is Python bytecode. It's pre-compiled stuff. And normally you can use some tools like uncompile6 or pyinsttractor. There's an X in there. pyinstextractor to extract. Or you could just even use the dis module in Python to disassemble. But that normally only works well for versions of Python under 3.9. It's kind of tough in all of the new or modern versions of Python, right? One question that I saw fly through chat, is this challenge based on a real incident? Yeah. All of the malware samples that we cut up are real. Granted, they are script-based malware analysis. So yeah. The AST, or like the abstract syntax tree for trying to cut up different language or new versions of Python, is not as easily done, I think, the newer versions. So we would struggle with this unless we use the DIS or dis module on that version of Python. pyinsttractor probably wouldn't be able to cut it up. Uncompile6 probably wouldn't be able to cut it up. But here's the thing. We got lucky. And this is real, again, based off a real sample. The zip archive included a pure Python script, regular source code, not precompiled bytecode. So we could look at our output.py and wonder what that is and what it does. It's more base 64. Base 64 encoding. And let's turn word wrap on so we can see and explore this. They exec or execute more code like an eval statement after it has unraveled what might be encoded in base 64. There are some other nonsense random comments here just to add bloat. Those aren't important, right? But while we aren't 1,000% positive what stage 3 would really do with the CPython 3134.pyc extension, it's pretty likely it's going to be tied to the exact same original source as this .py script. And to save you the trouble, if you did use the DIS or dis module on that Python compiled bytecode, it's going to be the exact same thing. You'll see the base 64 code. So let's go ahead and decode this. Thankfully, we can use Python, again, using the scripting language to unravel its own scripting malware, knowing that this exec function is the detonator. That is what will invoke the next payload, and we don't want that to run. We just want to see what will it do next. It's going to have to be Python code, so let's just remove that exec function. And then let's run what this base64 decode thing would do. Back in our terminal, rather than being in PowerShell, let's go to the interactive REPL, or read, evaluate, print loop for Python. Now I'm using Python 3.13. Remember, this code was in 3.12. We're still going to end up manipulating this A-OK because we're just using these functions to paste in that base64. Looks a little bit like a mess as I just put it on my terminal. Yeah, let me import base64. I forgot that line. And let's slap in all of that code. Now, this is hard to read because we don't have the new line characters in there. So let's actually set that as a variable to be like, what is this, stage 5? And then paste that all in again. So now I could just simply print the variable that I've set and staged as stage 5. Looking at this, we have output that looks like readable Python code. Heck yeah. So let me copy and paste all this, get this into a terminal that I can work with, or a new Sublime Text tab. And I guess this is like stage 5, technically stage 6. I don't know. We can call it stage 5. And let's move it up a directory so it's in here. Well, this is doing something a little bit different. We already have base64 imported in the context of this running Python, right? Because it's executed from the previous output one. You saw the exec function originally here. But it imports C types to be able to use some of the C, like low-level language C types on Windows. And it could then call a lot of Win32 API functions, things like virtual alloc to allocate memory, things like RTL move memory to copy or move memory into a new buffer. And then it could even execute some of this stuff. Let me turn word wrap on so this is a little bit easier to see and read here. But obviously, we have some shellcode being literally referenced by the variable name shellcode. And it uses XOR to decrypt, given a ciphertext bytes and a key that's provided as arguments. Looks like they do base64 decode that to hide those values. And they get the shellcode unraveled, allocate memory for it, and then try to copy over the shellcode into that memory space, and then execute that function. So it's going to run this shellcode, right? It's defining it all, getting the pointer for it, and then on the fly, getting this code injected to memory to run. But we could figure out what that shellcode is and does. Realistically, that's all we care about. Because again, we don't want this to run or execute or run the shellcode, but could we see or get the raw shellcode itself? So what I'm going to do is once again copy the pertinent parts of the script that I know that I need. I want to get the value of shellcode. I want to be able to XOR decrypt the contents there. And we already have base64 imported inside of our terminal or the interactive Python shell we've been working with, right? And in case you needed to see that again, we could import base64 just to make sure it's there. And let me paste in all of the code that we saw just a moment ago in that text editor. This will unravel the shellcode, so we have the variable and value determined here, but it won't actually execute it. It's just going to be available to us as bytes. Yeah? Now this is neat and handy, but there's no flag in there for the CTF. Question in chat, is the XOR to avoid antivirus detecting the shellcode payload? Yes. Yeah. More often than not, any of the obfuscation or encryption or odd tricks and techniques that you see, like even the stupid comments that were in here, they're all things to just add noise, add confusion, increase entropy. So a standard antivirus engine won't be able to make sense of it as easily with signatures. And even then the human analyst that might cut through this stuff will still be a little bit confused and overwhelmed. So let's see this in action. Now that we have the shellcode carved out, let's actually write that to a file. So I'm going to use some Python in the moment. Let me do it with shellcode.bin. Make sure I close that string. I do want to use write mode on that and as bytes. So with that little context manager, I can use, oh, you know what? Sorry, I did screw that up. I do want to make sure I have that variable accessible to me as filp, or like the file pointer. So let's use that and write out the shellcode variable that we have above, and then write it to a file. Once I hit enter on this, you can see it returned 130 characters. That's how much it wrote to that file. So let's exit our Python, and now we should see our shellcode.bin here. This is where we might start to struggle, because looking at what shellcode is, it's just shellcode, right? There's nothing more to it. And I got to start to wind things down, so let's finish this up here. Normally, when you're looking at raw shellcode, you could use some tools like Speakeasy. And let's go take a look at that one. Shellcode, Speakeasy. Yeah. Mandiant has a tool here for emulating Windows kernel and user mode shellcode to be able to see that in action. Super good. There's also scdebug for like shellcode debug to be able to see some of that material. Question in chat, but if the shellcode is XOR decoded, wouldn't or should antivirus still recognize the end shellcode? Yes, theoretically, hopefully, properly, fingers crossed, it should. May or may not. Right? Depends on kind of the engine, depends on what it does, depends on when it's getting in the middle of the hooks and stuff there. So Speakeasy is one option for shellcode. You also have scdebug that has some good write-ups and material there. I want to use Floss, which is a simple strings resolver, because you notice this shellcode wasn't all that big. If I were to try and run strings like you might naturally on any file that you're not familiar with on the shellcode bin or binary, there's nothing there. FGIU is not helpful. That's not a real flag. So what we got to do is try to unravel more from this shellcode, knowing it might use some clever tricks, like trying to dynamically allocate strings on the stack, like one thing after the next in memory. So let's use Floss, because that makes it pretty easy. Floss is the Flare obfuscated string solver that will automatically extract and deobfuscate strings from malware binaries. You could basically use it like strings.exe just to get a little bit better and enhanced basic static analysis. So it's good. It's cool. Normally, this is included in Remnux and in the Flare VM, but I think we could go ahead and work with it in Kali Linux, just downloading it for us to be able to work with it. Let me move the downloads Floss here, and then let me go ahead and extract out Floss. So now I should have in my current directory the Floss tool and program itself. Let's run Floss out of our current directory. And it will tell us, look, you need to supply arguments, you idiot. You need to actually tell us what you want to do. And you need to give it the file. You need to give it the sample. So let's give it shellcode.bin. That's all we need to provide, right? Well, I'm going to intentionally run us up against a wall, because we can't really tell that this is just pure shellcode right off the bat. It's expecting this to be a full Windows executable, like a .exe. So we need to go ahead and use format SC, like they suggest here, for 32-bit shellcode or 64-bit shellcode. I think we can safely test with 32. We can try it again for 64. But once this runs, this will smartly extract out and crap out the flag value for this challenge. So at the end of the day, the malware here didn't really do anything. It just dynamically had a CTF flag value on the stack, or in some of the tight strings that were tucked and hidden away there. So we could submit that for our flag, and there you go. That's the solution for day one's verify your human task. But I thought the run around through PowerShell, the mix up with a zip archive, thinking a PDF, and a little bit of Python, bytecode, compiled bytecode in the mix, and some shell code was still fun to walk through some script-based malware analysis work and all the sweet stuff that I would be chatting about at B-Sides Chicago for the live training. And my hope, the plan, what I intend to do is to add a little bit new material because I'd really like to start to play with Lua. Lua is the hot, cool kid on the block these days. A lot of chatter and conversations with the Lua language. So I thought it would be worthwhile to pour in some of that material as well. And we'll do that live and in person. But I hope you do get to take a look and join the party at B-Side Chicago. I think that's it. I got to go get to my next thing. So with that, let me stop sharing and I'll take a quick moment to look at chat. But then I got to bounce, guys. So many questions for you. Hit me up or the next live stream. I'll see you in Discord. Appreciate all of it. Looking back. Ooh, above question. How do you feel about the use of AI? Oh, and thank you so much. I appreciate the question that came through, I think maybe with the super chat. I'm so sorry I wasn't tracking. I was in the zone. I, for one, am all for AI. I have drank the Kool-Aid. I'm not like down the whole pitcher, but I play with Cursor. I've been doing a little bit of Claude Code. I think AI is still smart and worthwhile when you can use it as a tool. It is a tool. So, all right, everybody, thank you so much. Seriously, I got to run. I got to dash. I appreciate you coming to hang out with me for a little bit of solo speedrun script-based malware analysis, but hitting two birds with one stone. A little bit of B-Side Chicago hype, a little bit of Hunter CTF awareness and education, and that's it. That's the show. Let me run the sizzle reel, and I'll see you all later. JustHacking.com. Learn cybersecurity and focus technical training with JustHacking.com, where all-star instructors and industry experts provide hands-on, affordable, and practical learning. Across courses, free upskill challenges, hack-along training videos, and capture the flag competitions, there's always something to hack. With new content twice a month, all throughout the year, plus bi-monthly live streams, you can sharpen your skills in our on-demand and interactive lab environments. Advance your career and level up, regardless of your experience or budget. Forget all the noise and get to Just Hacking. Sign up now at justhacking.com.